Determine the sum to n terms of the following series. Okay, let us begin. So here we have a series. We have 1 multiplied to 2 multiplied to 3 added to 2 times 3 times 4. That's the second term. And then we have the third term, 3 multiplied to 4 multiplied to 5 plus the rest of the terms. So we have 2n terms. Our goal will be to find out the sum. So here, what we will do, we'll try to find out the nth term of this series. Now, we'll have to think about how to find out the nth term, because this series is neither an arithmetic series nor a geometric series. So what we'll do, we'll consider the first number of each of the terms. That means we have from the first term 1. From the second term, the first number, that's 2. Then from the third term, we pick up the value 3. And clearly we observe that these terms are going to be in arithmetic progression. And that's nth term that's going to be given by, so we have a standard formula, a plus n minus 1 times the common difference d. So here the first term is 1 and the common difference, that's 1. So that means we have n, the n. So that's going to be the nth term of 1, 2, 3, the sequence that is going to be in AP. Next, what we'll do, we're going to consider the second number in each of the term. So we'll start with 2. The second number in the second term, that's 3. Then we have the second number in the third term, that's 4. So the terms are going to be 2, 3, 4, 5, 6. That's going to continue. And these terms are going to be in arithmetic progression as well. So let's find out the nth term. So that's going to be 2 added to n minus 1 times the common difference d, so that's 1. So we have n plus 1. So this is going to be the nth term of the sequence with terms 2, 3, 4 and so on. And finally, what we'll do, we will consider the third number of each of the terms. So we have 3, 4, 5 and so on. So these terms are also in arithmetic progression, and the nth term will be equals to n plus 2. Now we can assume that let Tn be the nth term, of the original series, then we can say that then Tn will be simply represented as, take the nth term of the first sequence, multiply it to the nth term of the second sequence, and again multiply it to the nth term of the third sequence. So we're saying that this is going to be at the nth term of the series. We can verify it. So if we choose n to be equals to 3, so let's say n equals to 3, then in that case T3, which is going to give us the third term, that's simply going to be, we have 3 multiplied to, so 3 plus 1, that's going to be 4, multiplied to 3 plus 2, that's 5. So this is exactly the third term of the series. So this is how we can figure out the nth term of the series. Now that we have the nth term, our goal will be to find out this sum. Okay, so that means we want to find out the sum of 1, 2, 3 added to 2 times 3 times 4 added to 3 times 4 times 5 added to up to n terms. So here what we'll do, this is the same thing as taking the summation of the nth term, but we're going to replace the n value with k, such that we have tk, where k runs from 1 to n. In other words, we want to find out summation of, now what is tk? We could replace the tk with k times k plus 1 times k plus 2, where k plus 1 times k plus 2, where k is an index that runs from 1 to n. We can verify that if we want to find out the first term, then this we'll have to replace the k value with 1. So we have 1 multiplied to 2 multiplied to 3. That gives us the first term of the series. And since we have a summation side, we'll add, and to find out the next term, that means the second term, we'll replace k value with 2. So we get 2 times 3 times 4, which is going to be the third term. So this is a compact way of writing the sum. Our goal will be to find out this sum. Okay, let's try to find out the sum. So this is going to be equals to, we have summation k equals to 1 to n. So let's multiply the 3 factors. That's going to give us k cubed plus 3k squared plus 2k. Okay, now what we'll do, we're going to rewrite each of the summations. We have summation of k cubed where k runs from 1 to n, added to summation of 3k squared, but 3 is a constant. We can pull it out of the summation sign. So we have 3 times summation k squared. Again, k runs from 1 to n, added to summation. We have 2k. What we'll do, we'll pull out k from the summation. So we have 2 times summation of k running from 1 to n. Now we have a standard formula for each of the summation. So summation of k cube, this is simply the summation. This is the sum of the cubes of the first n natural numbers. So here we have n multiplied to n plus 1 over 2 whole squared, added to 3 times the sum of the squares of first n natural numbers. So the formula is n times n plus 1 times 2n plus 1 divided by 6. And then we have 2 times the sum of the first n natural numbers, that's given by n times n plus 1 whole divided by 2. Now when we combine all the terms, that's going to give us n times n plus 1 times n plus 2 times n plus 3 whole divided by 4. So I'm leaving the algebra part for you to try out. So here we have successfully showed that the sum of 1, 2, 3, 1 times 2 times 3, that's the first term, followed by 2 times 3 times 4, added to 3 times 4 times 5, and the terms up to n terms, that this sum is going to be equals to n times n plus 1 times n plus 2 times n plus 3 whole divided by 4.